Here, let us solve problems based on angle-side-angle congruence criterion. Now the question goes like this. In the figure shown, if AB is parallel to DC and P is the midpoint of BD, prove that P is also the midpoint of AC. So now, before we get into the details of the problem, I'll just give you a brief outline of how to look at the problem. P is the midpoint of AC. Now it's like very simple. I mean, if you have to prove that P is the midpoint of AC, what you have to do, you just have to say that AP is equal to PC or CP, whatever that is, right? So now if you want to say CP is equal to AP, what do you have to do? You just have to take the two triangles DPC and APB, prove that they both are congruent on some criterion. And once you do that, PC is naturally equal to AP. That is because you know that once you prove that the two triangles are congruent, the other corresponding parts of both the triangles are equal to each other. Now let us go into the problem. Now since AB is parallel to DC and transversal AC cuts them at A and C, we have angle PAB equal to angle PCD. Why? Because alternate angles. And similarly, AB is parallel to DC and transversal BD cuts them at B and D respectively. So therefore, we again have, this time it's a different one, angle ABP equals angle CDP. Why? Because even they are alternate angles. Now since AC and BD intersect at P, therefore angle APB equals angle CPD. This is anybody's guess. Why is it equal? Because this is such a famous reason, vertically opposite angles. So now thus in the triangles APB and CPD, we have angle ABP equal to angle CDP and we have BP equals DP because they've already told that P is the midpoint of BD. And obviously BP equals DP or PD. So therefore we have BP equals DP. And angle APB equals angle CPD. APB equals angle CPD, which is also proved because they are vertically opposite angles. So by ASA criterion, we have proved that triangle APB is congruent to triangle CPD. So by ASA congruence criterion, we have triangle APB being congruent to triangle CPD, and therefore we have AP equals PC, which is exactly what we had to prove. Prove that P is also the midpoint of AC. That is nothing but AP equals PC, because corresponding parts of congruent triangles are equal. This is the most important sentence after you prove that the two triangles are congruent. Here we have another problem which is like this. In the figure shown, angle BCD equals angle ADC. B equals angle BDA. We just have to prove that AD equals BC and angle A equals to angle B. That is angle 1 equals angle 2, angle 3 equals angle 4. AD is equal to BC. So let us see how do we go about this one. Now it's clearly given angle 1 equals angle 2 and angle 3 equals angle 4. Now angle 1 plus angle 3 equals angle 2 plus angle 4. which is nothing but if this is equal to this and this is equal to this, then if you add them both together, then they will be equal. This also comes from one of the Euclid's axioms, if you remember. Now, therefore, angle ACD equals angle BDC. You add them up, that is angle 1 plus angle 3, you get ACD. You add 2 and 4 up, you get angle BDC. Thus, in triangles ACD and BDC, we have angle ADC equal to angle BCD. CD equals CD. Why? Because it is a common side to both the triangles. And then we have angle ACD equals angle BDC. So therefore, again, we've got two angles equal and one side equal. So therefore, from the ASA congruence criterion, we have that triangle ACD is congruent to triangle BDC. Therefore, AD equals BC and angle A equals angle B. I'll repeat. Since triangle ACD and triangle BCD are congruent to each other, as a result of which AD equals BC and angle A equals angle B. The reason is corresponding parts of congruent triangles are equal.